Hi everybody. Okay, so this is Miss Ang Lien and we are doing a 2024 May paper. This is question 4. So let's get started. Alright, so this paper, or rather this question, is gonna be, the topic is gonna be on the alkali metal. So this is the group 1 metals. Okay, so this is a typical reaction. This is a typical practical that you would have seen or try out, or most of the time is a teacher's demonstration. Okay, your teacher will probably just let you cut the sodium, but she or he would actually be the one who put that metal into water. So group 1 metals are really reactive. Just in water alone, they are able to give us hydrogen gas, and this color solution would be depending on what is reacting. In this case, what will form is our sodium hydroxide, which is a really strong alkaline. Okay, so these are how the topics are interlinked. Okay, so we are looking at what two other observations that would be made. Okay, now since hydrogen gas is being mentioned, you should not mention anything such as bubbling or fizzing or effervescence, because they already tell you that hydrogen gas is being produced. So reading the question is really important. So what else can you write instead? Okay, so first thing first, maybe just write out the equation for you to better understand. So we've got sodium in water, and what we get is our sodium hydroxide and hydrogen gas. Okay, if you want to do a quick balancing, this is how we are balancing it. And if for those of you who wants to write out your state symbol, this is a very interesting equation because you utilize all 4 different types of state symbol in this equation. Lovely, isn't it? Okay, so back to the main thing here. They are asking for 2 other observations. So if you can look at the diagram, you will see that this sodium here is not sinking to the bottom. It's not a typical metal. So the first observation here would be the metal. Okay, on this case, sodium metal will float on the surface. You could also say that it would move on the surface of the water. It will not stay stagnant. Okay, because of the hydrogen gas that's being produced, it will propel. It just move it all over the surface. Okay, over time, what else will happen? Okay, the metal or the sodium metal would dissolve. Both the word dissolve or melt are acceptable here, or you could just say it gets smaller in size. And for those of you who have done this experiment, you would see a white trail being formed as the sodium is moving across the surface of the water. So these are typical observation that you will see for this demonstration. Let's move on to part B. Okay, part B, it's asking for how can we prove that sodium ion is present. What you can do here, this is linked to the topic of qualitative analysis. Okay, so we're looking at sodium ion, so technically it is our cation. So there are 2 ways to test for cation. One is flame test. In this case, we would definitely have to use flame test, or we can add sodium hydroxide in dropwise, followed by in excess. Okay, so in this case, we're using flame test, so we could, it's a 2-mark question. See, it's a 2-mark question, so you would have to write conduct flame test, and what you'll see for sodium is you will obtain or get a yellow flame. Okay, or in all, there are a total of 5 different colors for flame test. You need to get familiar with that. Okay, part C. Alright, so they are saying, okay, so we have these 3 group 1 metals. They react in the same way when added to water. State with reference to electronic configuration of this atom why these elements have similar reaction. So if you want to write out electronic configuration, is just a fancy way of just saying how does the electron, how are the electrons arranged. Okay, so go and pull out your periodic table, and you will see that for lithium, Okay, for lithium, there will be 3 electrons, sodium 11 electron, and potassium 19 electrons. So how would this 3 electrons arrange itself? It will be this. For sodium, it will be 281. For potassium, is 2881. Do you see any similarity here? Okay, at the end, all of them end with only one valence electron, and this is the reason why they undergo similar, if I can be even more precise, they will undergo similar chemical reaction, because they have all the elements above. Okay, if I want to be precise, lithium, sodium, and potassium have the same number of valence electron. If you are not very comfortable with the word valence, another alternative that you can use is outermost shell. Okay, electron in the last shell, basically. Okay, so that's the meaning of it. So that's 1 mark here. Okay, let's move up a little bit. Okay, so they give you a little bit of data. Okay, so with the data, you need to learn how to use and read the pattern. Okay, so we have got 3 electrons, 2 1 2 8 1, and then 2 8 8 1. So 11 electron and 19 electrons. How does the, as you go down, okay, then the number of electron increases. What else is increases? You will see that for lithium there's only 2 shells, right? And for sodium, you see there are 3 shells, and for potassium there are up to 4 electron shells. And with that number of shells, what is also increasing is the size, the atomic radius. Okay, visually it look like this, and then sodium we have like 3 shells, so you get bigger, and potassium. So atomic radius technically refers to the size of the atom. Okay, so they are giving away 1 mark to ask you to find the relationship between the atomic radius and the reactivity of the metal. So you do need to know by heart, okay, that the reactivity increases down the group. Okay, so what this means is, as the atomic radius increases, you see that as you go down, it gets bigger in value. Okay, as atomic radius increases, the metals, I would say the group 1 metals, get more reactive. Okay, so that is how we get this 1 mark. Now for those of you who are doing separate signs, then usually in paper 2 there will be like a 2 or 3 mark questions, depending on how generous they are, asking you for the why. Why is it that as the atomic radius increases, the group 1 metal will get more reactive? Okay, for those of you who are going to stay a little bit more, I'm just going to explain this in terms of 2 or 3 marks, so you can benefit from here. An extension, okay, we call it an extension, only for separate signs. Okay, but for those of you who are doing double signs, it's also good to know why. Okay, so sometimes don't just stay at, oh, okay, I know how to get this answer, but be a little bit more curious. Okay, so here, this is what happens. Now, going down the group, atomic radius increases. So this first statement basically shows you basically just trying to explain to you how this looks like. As you go down the group, the size of the atoms get bigger. Potassium is way bigger than sodium. Sodium is way bigger than lithium. Okay, because of the number of shells they have. Okay, then what happened is, let me just put it down. Okay, so this means that the outermost electron is further away from the nucleus. Now, what's the relationship between electron and the nucleus? If you pause and think about the chapter on atomic structure, the electrons are always in the shell, isn't it? But what is in the nucleus? In the middle of the nucleus, okay, we have things such as proton, which is positively charged, and we also have neutron, which is basically neutral. Now, when the proton, which is positively charged, is further away from the electron, the attraction is actually weaker, isn't it? So, like, I always give the example of like long distance relationship. If you are in Singapore and your boyfriend or your girlfriend is in USA, like your time difference is 12 hours or something like that, it's harder to maintain the relationship, right? As versus somebody who, like both of you in Singapore, so you get to see each other very often, your relationship or the attraction towards each other, it's going to be a bit stronger. Okay, but don't mind my analogy. All right, so what happens here? This means hence the attraction between the valence electron and the positive proton in the nucleus is weaker. The forces of attraction between the valence electron and the positive proton in the nucleus is weaker. And therefore, going down group 1, as the atom increases in size, the outer electron is more easily lost. Okay, so this is usually how we explain, but I'm just going to use the visual representation to help you understand this a little bit. Okay, so we have our electrons. I'm going to use lithium and our positive proton in the middle. Take a look at the distance. Okay, I'm just going to use green pen. If I look at potassium, which is the biggest one, the distance is further between the negatively charged electron and the positive proton. So because of the increase in distance, this forces of attraction will be weaker attraction between them. So if it's a weaker attraction, this electron is more readily to be given away as compared to lithium, the one on the top. Okay, the attraction, the distance between the positive proton and the electrons is so close, and so it is harder for this electron to be given away. So because of that, the reactivity for potassium is going to be way higher, okay, than lithium or sodium. Okay, so baseline, in summary, the smaller the atomic radius, the less easily it is for the atom, for the group 1 metal, to lose its valence electron, and therefore its reactivity decreases. Okay, I hope this helps.